Find the value of x in the following quartic. This quartic is actually in a pretty unique form that we can apply a special factorization technique to get it down into some factors. When you see a quartic that has something like this, where there's a power of 4, a power of 2, and then no power, so it has to be in this form, you can actually use the substitution method, where you can convert it pretty much into an equivalent quadratic and then use something like a quadratic factorization method, like maybe a cross method, to factorize it a little bit. Once it's been factorized beyond that point, then you can just put back what you substituted, which was that a, and you'll be able to continue to factorize a lot quicker from there. So I will go through this a bit slowly because it's a bit tricky, but it's a great technique to have under your belt for factorizing. It makes it a lot quicker than doing it the long way of long division or anything like that. So here you can see I have a power of 4, a power of 2, and a constant. So this is a candidate for this technique. The first step is I can rewrite the power of 4 as something squared. And then I have 5x squared, I can put this in brackets, plus 4. And this is an optional step, but it gives you a better idea of what we're doing next. You can sort of see that this is something squared, this looks like just a separate term, and then there's nothing here. So it's starting to look a bit more like a quadratic. And this is where I'm going to take a letter, usually capital A, as a variable, and I'm going to let it equal to x squared. Now, everywhere I see x squared, I'm going to replace it with the a. So I have a squared minus 5a plus 4 equal to 0. And hopefully now you can really clearly see that this is just a quadratic. We have an a squared, an a, and a 4. So this is a quadratic that we can factorize using our usual techniques like the cross method. So on the left, I need 2 a's. And on the right, I need 2 things that multiply to give 4 and add to give negative 5. So that might be negative 4 and negative 1. Just going across the check, so we have minus a minus 4a, and that does equal to minus 5a. So we've got the correct cross. And now I can just put that down, so I have a minus 4 and a minus 1. Now this is actually looking very good already, but I'm just going to replace it back with what I had, because obviously the a is something I invented to help myself. I'll just replace the a back with x squared. So I'm going to replace x squared equal to a. And I'm putting that here, so x squared minus 4. And then I have x squared minus 1 equal to 0. All of these can now be factorized further using difference of 2 squares. So this one factorizes to x minus 2, x plus 2. And this one factorizes to x minus 1, x plus 1. I'm going to erase this, make some space. Fantastic. So you can see that this factorization, we got 4 brackets, and that was actually quite a quick process if we recognize that we can use the substitution technique. And now I'm ready to do my null factor law. So from this one, I get x equals to 2, x equal to minus 2, x equal to 1, and x equal to minus 1. And those are my 4 solutions to this problem.